Good morning, all the people that were taking the calculus test. This is a lesson that we learned today while you're taking the test about refraction. The question is, why does light bend when it goes through things like glass or water? You've seen this at swimming pools. We learned this when we did lenses. The glass is on my face right now. If you look, the light bends and it changes the angle so that I can see better when I'm looking through my glasses. Well, before we can address those problems, we have to look at a couple things. We know that the speed of light in a vacuum, we use the letter c. So in a vacuum, there's no restrictions on the light. The light can go at its full or maximum speed possible. We know this is 3 times 10 to the 8th because we've learned this before from electromagnetic waves. Now, the velocity of light in water is not the same. Notice that it's only 2.66, not 3 times 10 to the 8th. So it slows down considerably when it goes through water. All right, now to keep an idea or some idea of what the materials and how they affect it, we come up with something called the index of refraction, letter N. This N, let me write this down, is index of refraction. And this number, this index, you take the c, which is the speed of light in a vacuum, and divide it by the actual velocity in the material. So let me complete this one, for example. For water, we have 3 times 10 to the 8th meters per second, divided by 2.66 times 10 to the 8th meters per second. The index of refraction for water is 1.33. Notice there's no units because meters per second divided by meters per second is just a ratio. So the N value for water is 1.33, which gives us some idea on how thick it is, how restrictive it is to the velocities. Now what I'd like to do next is take a look at the value for glass. This is crown glass, which is used for optics, and the N value for crown glass is a bit thicker, slows the light down a little bit, is 1.52. So my question to you is, well, if I know the index of refraction, how restricted the material is, can I now figure out the velocity? So the velocity in crown glass, I'd like to calculate it. That's my question. So to find that, we know that N is equal to C divided by V. 1.52 equals 3 times 10 to the 8th meters per second divided by the velocity in the crown glass. And if you actually compute that, I think it comes out to 1.97 times 10 to the 8th. Notice that as the index of refraction increases, the velocity starts to decrease. The thicker the material, the more restrictive it is, the slower the light's going to go.